Right. Paper 8, question number 1, given there, fx given x squared plus 2 lambda x plus lambda plus 2, right? Given lambda is a real number, so that the minimum value of fx is this, right? To find the minimum value, first of all, we'll complete the square of this right hand side. Now, you know the steps in completing the square. We put a bracket, put perfect squared. Inside the bracket, this x squared, we write x, and x coefficient 2 lambda, no? This we have to divide by 2, then we get lambda, right? And then the last two terms, lambda plus 2, and we always subtract the perfect square of the second number inside the bracket this way. Okay. Now fx minimum going to be, people, for this fx to be minimum, the right hand side should be minimum. That means this is the constant, you can change that. This perfect square should be minimum, but you know minimum value of a perfect square is 0. When this perfect square becomes 0, the right hand side is minimum. So therefore, fx minimum going to be this. That occurs when this x plus lambda equals 0. That means x is minus lambda. Okay. Now fx minimum is this. Right. That first one come in, no? Minus lambda squared plus lambda plus 2. Hence find the range of lambda for fx to have distinct real roots. People, now you can see here x squared has the coefficient plus 1. Therefore, the graph is minimum. Right. The minimum graph can be like this, people. It can be like this, or it can be like this, touching the vertex x-axis. The other possibility, right, it should be like this. You know, in this case, the graph fx has no real roots. Here we have graph has coincident real roots. In this case, right, graph has two distinct real roots. People, when we consider this occasion, the minimum value means this height. In this case, this height is positive. In this case, this height is 0. In this case, this height is negative. Understood? So therefore, in order to have a distinct real roots, this minimum value should be negative, right? So therefore, this thing should be negative, right? For distinct real roots, right? This thing, the minimum value should be negative. That means lambda plus 2 minus lambda squared should be negative. So we'll multiply this by minus 1, lambda squared minus lambda minus 2 greater than 0. You know, when you multiply an inequality by minus sign, the direction gets opposite, right? So now we have to find the range of this. Simple inequality here we have. We can factorize this first. When you factorize that, this way, greater than 0. Right, so then factor is going to be lambda minus 2 and lambda plus 1. Right? You get this is 0, lambda 2 here, minus 1. We don't have equal sign here. Circle here. Circle here. Right. Yeah, when you put 0, 0 is in between minus 1 and 2, people. When you put 0 here, put 0 here, minus lambda plus 1, minus 2 greater than 0 is false. So therefore, this does not satisfy, right? Then this should satisfy, this should satisfy. Then the range come in, people, asking what? The lambda range, no? Find the range of lambda, right? So then, therefore, lambda should be less than minus 1, or lambda should be greater than 2. Should be the range of lambda. Right. Question number 2. Question number 2, limit x going to pi by 6, right? Cos x plus pi by 3. Cos x plus pi by 3 divided by root 66 minus root pi. Ask to take this answer as minus root pi over 3. Okay. Then this answer I can write like this. Limit x going to pi by 6. This cos I can write sine 90 minus x plus pi by 3. This I can write cos, because you know sine 90 minus angle mean people, sine 90 minus angle mean cos that angle. Then when you simplify this here, sine 90 minus this angle means the answer is cos x plus pi by 3. This is coming. It won't change. So now I write this one, okay, this way. Okay, now the next line is I simplify this and I multiply the numerator and denominator by the conjugate of this, right? Okay, then what you get is this. When I simplify this, limit x going to pi by 6. Here when you simplify, pi by 2 minus 90 minus 60, it's 30. Sine 30 pi by 6 minus x. Okay. Conjugate, by that conjugate we multiply. Root 6 plus root pi. And here root 6 minus root pi by its conjugate when you multiply this way we get, right? Then you can see people there, when you simplify this, a minus b, a plus b form, no? Right. And meantime, I take minus sign out from this. So you can write sine this angle as sine minus, within bracket, x minus pi by 6. That minus sign I can take out like this, minus limit x going to pi by 6. Then this is going to be sine x minus pi by 6. Okay. Here we get 6x minus pi, no? The product. And this root 6x plus root pi, this way. Now this 6 also we take out. And the limit x going to pi by 6 I put there. Then what happens is this, minus 1 over 6. People, this x going to pi by 6 means x minus pi by 6 going to 0, no? So therefore I can write it that way. X going to pi by 6 mean x minus pi by 6 limit going to 0, this way. Right. So then here what you get is sine x minus pi by 6 divided by x minus pi by 6, right, into limit x going to pi by 6, this part, root 6x plus root pi. Okay. Now it's okay, no? You can see here this x minus pi by 6, if we take as theta, limit theta going to 0, sine theta divided by theta, then this whole thing should go to 1, right? Should go to 1. So it means this thing equal to 1. Then here once I put pi by 6, that 6 and this 6 you can cancel down, root pi, you know. Then we get this way, minus 1 over 6 into 1 into pi by 6 when you put here, root pi plus root pi, right? Root pi, 2 root pi, 2 and 6 you can cancel down. Then we get minus root pi by 3. This way. This is the answer. Right? That way you can take the answer. Okay, next one, number 3. Number 3, the next one. Show that sine 3 pi by 5 is equal to sine 3 pi by 5. People, I can write this one, this is sine pi minus 3 pi by 5. Because you know, sine 180 minus theta is equal to sine theta. This you know. Then I can write that sine 3 pi by 5 this way. Sine 3 pi by 5, I can write sine pi minus 3 pi by 5. Okay. Then we can simplify inside this. Sine pi minus 3 pi, 2 pi by 5. Here we get sine 3 pi by 5. Right. Now, you know sine 3 theta formula. Sine 3 theta formula is 3 sine theta minus 4 sine cube theta. There, this sine 3 pi by 5. I take this theta as pi by 5. Then this sine 3 pi by 5, I can write 3 sine pi by 5 minus 4 sine cube pi by 5. And here, right hand side, we have sine 2, this 5 by 5 I take as theta. Here we have sine 2 theta. It is 2 sine theta cos theta. Okay. Then we can write the left and right. This one, 3 sine pi by 5 minus 4 sine cube pi by 5 equals to sine pi by 5 into cos pi by 5. Then 1 sine pi by 5 term you can cancel down. This way, here we get then the power 2. Here we get only 2 cos pi by 5 on the right hand side. Now, here we get 3 minus 4 sine squared pi by 5. I can write as 1 minus cos squared pi by 5. And here 2 cos pi by 5. Right. Now, remove the bracket here. Minus plus 4 cos squared pi by 5. Reduce this side, minus 2 cos pi by 5. And then here we get minus 4 and plus 3 is minus 1 equals 0. Okay. Now, we can find the two roots or two answers for cos pi by 5 by using the quadratic formula, right? Right. So then there we get. All right. What are the two answers for cos pi by 5 we get? Use that quadratic formula, x equals minus b plus or minus square root of b squared minus 4ac divided by 2a. Using that, you can find two answers here, right? Okay, then we get x equals minus b going to be this minus 2, x equals minus b plus or minus square root b squared minus 2 perfect squared b squared minus 4 a c divided by 2 into 4. Here 2 plus or minus, here 4 and 16 divided by 8. Here people, we can write 4 plus 16, 20. 20 we can write as 0.5. Right, so then this is 2 root 5, no? This way. Cancel down by 2. We get cos pi by 5 equals 1 plus 2 minus root pi by 4. Cos pi by 5. Right. Pi by 5 means 36. This angle 36. Okay. Cos 36 should be positive because 36 acute angle, first quadrant. First quadrant, all three ratios sin, cos, tan positive. Therefore, cos 36 should have a positive answer. Therefore, if you select this minus sign, the numerator is going to be negative. That is impossible. Therefore, this plus sign we have to select. Since cos pi by 5 positive, answer of cos pi by 5, we take this plus sign. That way, we can take the answer. Question number 4. Partial fraction part. Express this in partial fractions. 3x over x minus 1, x plus 2, no. The denominator contain in non-repeating linear factors. 3x upon x minus 1 into x plus 2. Right. Now write partial fractions. A over x minus 1, b over x plus 2. Right. We multiply both sides by x minus 1, x plus 2. We get 3x, a times x plus 2, b times x minus 1. Right. We equate the coefficient of x power 1. Here we get a, here we get b. A plus b equals 3. X power 0 coefficient now we can equate. That means in the left and right constants. Here we have 2a, there we have minus b. 2a minus b should be equal to 0. This gives us b equals 2a. When you put that b equals 2a here, a plus 2a is equal to 3, a equals 1. When a equals 1, b is 2. a1, b2 coming. Right, no? Then we can write the partial fractions. Right, no? Then partial fractions we can write people like this. 3x upon x minus 1, x plus 2. Right, substitute for a is 1 now x minus 1. And b, 2 over x plus 2. Right, now asking what? Hence find the partial fractions of this. 3 upon x minus 1, 2x plus 1. Right. So to take this, what I do is here, in the left and right, replace this x by 1 over x. Right? Put 1 over x, 4x. So to get 3 into 1 over x, 1 over x minus 1, 1 over x plus 2. Right, 1 over x minus 1 over x plus 2. Right. Here we get 3 over x. Here we get 1 minus x upon x and 1 plus 2x upon x. Right. Here 1 over 1 minus x over x. Here 2 over 1 plus 2x over x. Right. People, you can see here, this x we can write via here, no? that x and this x you can cancel down. Then in the left and right, this all x's you can bring at the numerator. To the numerator you can bring this here, this here, this here. Those x's you can cancel down. So then it will cancel down here itself. Right. So then we get the partial fraction of that. What? 3 over 1 minus 6, right? And 2x plus 1, no? Alright, 1 minus 6 I can write, people, taking this minus sign out, this way, x minus 1. Then minus sign coming to the numerator. This one I can write. Alright, okay. Now, here, I can write this one, take minus sign out, minus 1 over x minus 1 and 2 over 2x plus 1. Correct, no? Yes, now we multiply both sides by minus sign. This will be plus, this will be minus. Then we get the partial fractions of that. Right, so then multiply by minus sign we get 3 over x minus 1, 2x plus 1. One over x minus 1 minus 2 over 2x plus 1. Right, no? Right. Number 5. Question number 5. It says find the straight line L passes through the intersection of the lines these two. The perpendicular distance from origin to L is 1 unit. Find the equation of line L. Right. The given line passing through the intersection of, right? These are two lines. First line given as 3x plus y minus 1 equals 0. Other line is x minus 1 equals 0. The required line is this. Required line is this. Right. This is line L. This is line L. Equation of L you can write, people. How? Equation of line L we can write, since it passes through the intersection of this and this. Equation of L we can write how? 2x plus y minus 1 plus lambda times x minus 1 equals 0. What is lambda? Lambda is a parameter. Lambda is a parameter. Right. Then I can rewrite this 2x and here lambda x. Now take x out. Then we get lambda plus 2 times x. This and this we take to then take x out. Lambda plus 2. And here we get y. Right. And here minus lambda minus 1. Should be equal to 0. Right. To the line this L, the distance from the origin given as 1 unit. Alright. Here we have origin coordinates 0, 0. From here, the perpendicular distance given 1 unit. 1 unit. Okay. Then you know, to find the perpendicular distance from an external point to a given line. The coordinates of the external points we substitute in the equation of the line for x and y, and we take modulus, right? And we divide that by the what people square root of x coefficient squared and y coefficient squared. Okay. All right. So then we get, when I put that 0 and 0 here and here, we get only minus lambda minus 1 inside the modulus like this, divided by x coefficient squared, lambda plus 2 perfect squared, plus here 1, its root is equal to 1. Right. Here you can write square in both sides. When you square people this, what happens is this modulus will eliminate. Inside that, what do we have? That we have to square. There also, once you take minus sign out, when you square that, that will be plus. Then we get lambda plus 1 perfect square. Right. When you square this, the root will eliminate, and then use a cross multiplication. Then we get this way, lambda plus 2 perfect square plus 1. Right. Now simplify for lambda. Lambda squared, 2 lambda plus 1 here, lambda squared, 4 lambda plus 4 plus 1. That way we get when you simplify this. Lambda squared plus 4 lambda plus 4. Right. Lambda squared you can cancel down. 1 and 1 you can cancel down. Once you take this side, we get 2 lambda. Our right hand side we have 4 lambda minus 2. Correct, no? Right. Lambda minus 2 mean, people, you can put lambda minus 2 here. Then we get the equation of L. How? Lambda minus 2 going to be here. Y minus 1. Right. Therefore, equation of L. Therefore, L, we can write equation of L is this. That means this. Lambda minus 2 means this one come, x term 1 come. It is 0, no, x coefficient. Y. Right. Even you put minus 2, minus plus 2, minus 1 is 1. Y plus 1 is equal to 0. Okay. Number 6. Right. Question number 6. Right, there you are given number 6, point capital A is at a height 3h vertical above a point O on the ground. A particle is projected vertically upwards from the point capital A with initial velocity u. If the maximum height of the particle above the point A is h. By using velocity time graph, show that the velocity of the particle when it falls on the ground is 2 times root 2gh. Right. Okay, then I can take it like this. Now, this is the ground. Point A is here at height 3h above the ground. From the point A, a particle is projected upwards with velocity u. It goes to a maximum height h, and then comes under gravity. Then when it comes to the ground, that should descend total height OH. Okay. Now, yes. When we sketch the VT graph here, this is the VT graph. First, it begins with velocity u upwards velocity comes to 0 here like this. That means the highest point. Then this area should be equal to h. From here it comes from down, descending total height for h. So therefore the VT graph comes below the time axis like this. Right. If this is theta, this is also theta. Here O, velocity axis positive, velocity axis negative. We need to find this velocity. Suppose minus v. This tan theta, you know, people, g, no? Tan theta is g. Let us take this time as t1. Then, by this triangle, I can write tan theta here, this side divided by this side. This side going to be v. Don't take this minus sign. Minus sign says the particle moves downward. Right. Tan theta v over t1. Then we can subject t1. Bring t1 here, tan theta here, that is g, no? Right. t1 equals v over g. And this area, people, should be equal to 4h, no? Right. Now you can write this area. What is that? Half base t1 into perpendicular height v should be equal to 4h. Right. Then t1 v over g, half v over g into v 4h. Then here we get v squared, 2g 8g h. Take v. Root of 8 is 2 root 2. This way we get this velocity, right? This is how we take that answer. Number 7. Number 7. Right, no? Right, number 7, people, this way, some steps of staircase shown in the given figure. A particle projected from capital A with velocity u horizontally just passes through the point B. Yes. Secondly, the same particle projected from A with velocity w horizontally just passes through the point C. Show that w equals to u over root 2. Right. We'll see to take this. first thing people, first particle, first occasion when this particle is projected with velocity u, we are given the particle just passes through the point B. Yeah, this way. Then for this AB motion, you can apply equation of motion like this. First we can write for AB motion, S equals ut plus half at squared downward. The vertically downward direction displacement is A. Initial velocity 0, half g t squared. Okay. Then you can subject t squared to A over g. T squared, right? Now we can apply S equals ut rightward. During the motion, it moves rightward B. B equals u times t. Right. Then we have t squared like this. Then we'll square this one. U squared, t squared. Then we can write b squared, u squared, t squared is 2 a over g. Right. Then we get b squared as 2 a u squared over g. Is our b squared. Right. Secondly, given that the same particle is projected horizontally with velocity w, then that passes through the point C. Secondly, the same particle projected from A with velocity w horizontally just passes through the point C. Right, this way. This way, right? Right. So then that motion you can write again for AC motion. For AC motion, we can put S equals ut plus half at squared downward, right? So what is the height? This is A. This is A. It's 2A. 2A. This is 2A. U0 half G. They'll take T1 squared. Then you can subject by this T1 squared OA over G. Right. Now for the same motion, we apply S equals ut rightward. What distance it moves rightward once it comes from A to C? This is A. Sorry, this is B. This is 2B. Then we get 3B, no? 3B. U is W. T1 squared. T1 here. Right. Now square this. 9B squared equals W squared T1 squared. Substitute for this T1 squared. This answer. 9B squared equals W squared T1 squared. OA over G. Okay. Now 9 times this B squared. Here we have. Put that here. 2AU over G. 2AU over G. For this B squared, I substituted by this 2AU squared over G, no? 2AU squared over G. 2AU squared over G. Here you have U squared. 2AU squared over G is your B squared, right? 9 2A U squared over G, right? Equals W squared. W squared into OA over G. These two you can cancel down. This and this you can cancel. 2 and this we can cancel down. 9 U squared equals 2 W squared. Get your square root there. 3U here. Root 2 W. Bring this way here. W equals 3U over root 2. This way we get that. Huh? This way we get that answer. Right, number 8. Work power energy question, right? Work power. Right, no? Yeah. It says a car of mass 1200 kilograms moving on level road against a constant resistance 400 newtons work its engine at a constant power 2.4 kilowatt. When the speed of the car is v, show that the acceleration 6 minus v upon 3v. Deduce the maximum speed of the car under the same conditions. Right? Okay. We'll see how to take that. Now it's okay, no? Yes, car 1200 kg, right? Kilogram. (1200 kg). Right. Its engine works with the power 2.4 kilowatt. Right. We are given this moves with velocity v, constant resistance given 400 newtons. Then you know a tractive force coming to the car like this. Suppose F, you know H equals Fv. V is the velocity, F is the tractive force, H is the power. H is the power. Right. Then we can subject this F H over V. Right. V here, H in watts we have to put kilowatt 2.4 into 10 to the power 3 when we convert that to watts. Right. Now what it's asking is people the acceleration, no? Yeah, we can apply F equals ma. F equals ma when we apply this way. Tractive force F minus 400, right, is equal to mass 1200 and acceleration will assume as a F 2.4 into 10 to the power 3 divided by V minus 400, 1200A. 2 zeros you can cancel down, right? These people here. And here we get 24 over V. Right. By another 4 also we can simplify this. 24 over V minus 4 minus 12A. Cancelled by 4. 3, 1, 6. 6 over V minus 1. Then we get 3A. Right. So then simplify here. 6 minus V divided by V, bring this 3 here, 3V equals A. This is the acceleration. Okay. Now what is asked next? Deduce the maximum speed of the car under same conditions. Under same condition means the same power, same resistance at the maximum speed, people, you know, if and this 400 should be equal, that location, acceleration 0 at the maximum speed. At the maximum speed, acceleration 0. That means this must be 0, right? You can write at the maximum speed, a equals 0. A is this. This should be 0. V equals 6. V equals 6. Right. Number 9 next. Number 9 says a uniform rod AB of weight 5W and length 2A is smoothly hinged at A. The rod stays in equilibrium, making an angle pi by 6 with the horizontal. By a force, if applied at B, perpendicular to the rod. Find the value of F. Also find the magnitude and direction of the reaction at the hinge A. Right. Number 9. Yes, this is the rod. A here. Right. B here. Rod is resting, making an angle 30 with the horizontal. This angle 30. Uniform rod, center of gravity at the midpoint. Weight given as 5W. At the hinge, there is a single reaction. That single reaction we can really mark asking people their magnitude and direction of the reaction at the hinge A. Magnitude and direction of the reaction at A. Right. Magnitude we can first find. Right. We will take here horizontal component I take as X. Vertical component I take as Y. Right. So then first to find this F, I can, right? Then the resultant going to be this way of this X and Y. That resultant only be defined as a reaction at the hinge A, R. Now, we take moment around A for the equilibrium, right? The length given as 2A, no? Uniform rod, center of gravity at the midpoint. Moment of F into A. By W, this length from here to here, A cos 30. By W into A cos 30. A and A you can cancel down. F can be subtracted. Cos 30. Root 3 by 2, no? By root 3 W. Here 2 and this 2. F is this. By root 3 W by 4. And now, asking to find what people magnitude and direction of the reaction at hinge A, right? When you resolve for the equilibrium of the rod rightward, we get X equals here, right? This is 30, this is 60, F cos 60. Cos 60 is half. X we get y root 3 W here cos 60 half, no 8. Right. Resolving vertically, we get a y plus F sin 60 is equal to 5w. Y you can write 5w minus f 5 root 3 w by 4 sin 60 means root 3 by 2. Okay, sin 60 root 3 by 2. Y. You can take here yw here 5 root 3 people, there we get 15w over 8. Correct, no? Root 3 3 5 into 3 15 w by 8. Right, now we can write here, take this 5w out. Here 1, 8 comes here. When you take 5w out, people, here we get another 3, here 8. Correct, no? 5w when you take out, there we get 8 minus 3. Then we get here 5, y is 25 w over 8. Right, so then reaction mean x squared plus y squared root, right? R is equal to the x squared plus y squared root. Okay, then you can take that answer for R. Right. R can then be found x squared means 5 root 3 w by 8 perfect squared. X squared, y squared 25 w over 8 perfect square. Right. Here 5 w by 8 we can take out. 5 w by 8 first p square. From here also 5 w by 8 first p square, that we take out. Then 5 w over 8 only coming out. 5 w over 8 when you take out, here root 3 squared is 3. Here w over 8 we have taken out, another 5 we have taken out, another 5 is here. 5 squared 25. Right. Then R comes as 5 w over 8. 25 plus 3 is 28. 28 root means 2 root 7. 28 we can write as 5 into 7, no? 2 root 7. This and this we can cancel down. Are going to be 5 root 7 w divided by 4. Okay. The direction you can find if we take this angle as alpha, tan alpha can be found. Tan alpha going to be y over x. Right. Your y 25 w over 8. Your x 5 root 3 w by 8. W by 8, w by 8 you can cancel down. 5 here, 5 here, 5 over root 3 alpha is equal to tan inverse 5 over root 3. Is it? Right. Last question number 10. Okay, no? Number 10. Right, we'll erase this all. Number 10 says let A and B be two points with Partial vectors I plus 2j, 3i plus j. X-axis, you know, along this unit vector I. Y-axis here, right? Unit vector is j. Point A has Partial vector I plus 2j means point is 1, 2. Here. 1, 2 is the point A. Then the Partial vector is I plus 2j. Point B, 3i plus j. Here. Point B should be 3, 1. 3i plus j is the Partial vector. Right now. 3i plus j, I plus 2j, I plus 2j, 3i plus j. Right. A vector PQ of magnitude 2 root 5 acts in the direction of the vector AB. Right. AB vector we can write. Now we are given PQ vector like this. PQ vector we are given that acts in the direction of AB. Right. PQ vector magnitude given 2 root 5. Magnitude means this length. Okay, 2 root 5. Then asking to find the vector PQ. Right. We'll first find AB vector. AB vector you can write, people, position vector of B minus position vector of A. Second letter position vector minus first letter position vector. AB vector. Position vector of B, 3i plus j. Position vector of A, I plus 2j. 3i minus I, 2i. J minus 2j minus j. This is the AB vector. I am going to find AB vector modulus, its size. Square root of I coefficient squared plus j coefficient squared. This is root 5. Is the size of the AB vector. Now, I am going to find in the direction of A to B, suppose the unit vector is U. You know unit vector means size is 1. Right. So then unit vector in the direction of AB vector, if I take as U, that you can write AB vector divided by AB vector modulus like this. This is the definition of unit vector. Vector AB 2 I minus j. AB vector modulus root 5. Right. Now people we can write PQ vector. How to write? A vector we usually write how, people? Its modulus multiplied by unit vector in the direction of that vector PQ. We are given, people, this PQ vector is acting in the direction A to B. Therefore, in the direction P to Q, that direction also the unit vector is U. So therefore, PQ vector when you write, its modulus multiplied by U, we have to write. Then we can write PQ vector. PQ vector modulus given as 2 root 5. Unit vector we found here, people. What this? 2i minus j divided by root 5. This and this you can cancel down. Then we get PQ vector multiplied by this 2, 4i minus 2j. This is the PQ vector. Find the vector PQ. If the position vector of P is 2i minus 4j, show that the position vector of Q is this. Right. Begin now. We can write people like this. PQ vector when you write, we write this as how? Position vector of Q minus position vector of P. second letter position vector coming first minus first letter position vector. Right. PQ vector just now we found 4i minus 2j. Right. Position vector of Q only we need to find. Keep that there. Position vector of P given as 2i plus 4j. Then to get this position vector of Q, take this to this side. Therefore, plus 2i and 4i, 6i, plus 4j and minus 2j is 2j. This is the position vector of Q, 6i plus 2j. Right, this is how we take those answers. Right now? Okay then.